All right, so I know some of you are going to see this and start groaning, but we're going back to what we did in chapter 2, and we are creating piecewise functions. So a function that's made up of several pieces from different functions is called a piecewise function. Now, these notes are literally copy and paste from chapter 2. So this is not new, except for now we have a lot of other functions that we've looked at. So a piecewise may or may not be continuous. And what that means is you might have one function that looks like this and ends, and then the next function might start on the same point and go down. Okay? Or you may, this and this right here is continuous. You might have a function that looks like this and ends, and then your next function starts up here and does something like this. This is not continuous. So if you have to pick up a pencil, then it's not continuous, all right? So it may or may not be. So you might have something that's all one line, or you may have little jumps in there. So in other words, it may have discontinuities, or jumps. And that's okay. We can do that. So let's start with an easy one. So this first one that we have here is a linear piecewise. So I know that because this is the function of a line, and this is a function of a line. So remember, our line is y equals mx plus b. So what we did back in chapter 2 is we said, okay, we're going to graph this line, and this is in y equals mx plus b. So my intercept is 1. And my slope is 1. So I'm going to go up 1 over 1, and I'm going to do this in both directions. And I'm going to do this pretty light, and I'm just going to draw a line that looks like this. Okay? Now I go to this part of it, and this part here is my domain. And my domain says x is less than 0. So everything this direction of 0. Well, here is 0. So this is when x equals 0, right? So this is x equals 1, x equals 2, so x equals 0 this way. So that means I'm going to go in here and I'm going to erase all of this part of my function, okay? Now, one more thing I have to look at, and that's this. This is less than. So this is not a closed-in circle. It's going to be an open circle going this direction. All right, so now I can go to my second graph, which is this one. And I start at 1 again, so I'm here at 1. And this says I have a slope of -3. So I go down 3, 1, 2, 3, over 1, down 3, over 1. Now, my graph is already on this side. So because it's already on this side, I'm not even going to make my line go this direction because I know it can't go this direction. Because this is saying when x is bigger than 0. So here's x equals 0 again. So I want all the values that are going to be bigger. So all the values bigger than 0 are going to go this direction. X equals 1, 2, 3. Those are all bigger than 0. Okay? Then I have to look at my inequality. So right here. And now I'm going to color in that circle because it's included on this one. And just by chance, this is continuous. So by chance, I know that this line and this line are going to meet, and they're going to meet at this massively huge dot that I made right there. Okay. All right. So now let's go on and look at some more difficult ones. So now that we know a lot more functions, we're going to go in here and we're going to graph these differently. So I'm going to do this in pencil. So first thing I'm going to do is I'm going to look at my top function right here. And my top function is x squared. So I know, and this value of a is positive, so I know that that is going to look like a u. All right, so I'm going to graph this in this form. So my vertex here, so this is my first function, my vertex here is 0, -2. So 0, -2, I have this point right here, and I know that I'm going to go up 1 on both sides, and I'm going to have this U-shaped curve like this. Okay, so now what I want to do is I have to look at my domain. So this says I'm going to keep this curve for everything less than 1. So here's 1. So if it's less than 1, I'm going to erase this part of my graph. Okay, so here's what I have. Let me just go ahead and make this a different color now. So here's what I have on my graph, and I'm going to go to this point here, and this point here it says less than, so this has to be an open circle. All right, so now I'm going to make the second graph this blue graph right here. And I know that this is cubic, and my cubic graph is going to look like that. So again, I'm going to go back over here and I'm going to graph it. So what I have here is that this is going to start at, my vertex for my second graph is going to be at 2, 0. So 2, 0, so here's my starting point. And what I know about a cubic graph is I'm going to include this point and this point. Okay, so my graph is going to look like this. All right, but now I have to go in and erase a little bit. So this says when x is greater than or equal to 1. So this part of my graph that goes down, I'm going to delete that because I don't need it. So the only part of my graph that I care about is going to be at this point 1 and greater. So these are all my x values that are greater. Now, if I go back in here, this is included. So I'm going to color that circle in, and this is also a continuous graph. It's going to keep going. All right, let's try another one. So what I know about this guy right here, I'm gonna stick with my color. So here's my pink graph. I'm going to write down what I know about my pink graph. So I know that it's going to be an absolute value graph, and my absolute value graph is going to be a V. And I know that this is negative out here, so it's going to be actually a V that goes down. And my vertex of this V is going to be negative 3, 4. Okay, so if I go over here to negative 3, 4, 1, 2, 3, 4, this is where my graph is going to start. And I'm going to look at this, I'm going to say, okay, my graph is going to end at negative 1. So I know going this direction, this part of my graph is going to stay, but here I'm going to stop when x equals negative 1. So I'm going to have a point here, I'm going to have a point here. And this point, because this is equal, this point's closed. So my graph is going to end at that point. Now there's an arrow on this side of my graph because this says x is less than. So it's going to keep going and keep going and keep going. But on this side, I don't have an arrow because this says it's going to end when x equals negative 1. So it's going to end right here. All right, so now let's go do the other one. So now I have this blue section of my piecewise. So here's what I know about that. I know that it's a quadratic. I know that it's going to shape down. I'm going to have a U shape down, and I know that because this is negative. And my vertex of this guy is going to be 0, 3. So if I come over here, 0, 3, I have my vertex. I see that this, we only care about what happens at 1. So even though this is my vertex, if I only care about what happens at x is greater than 1, I've got this point here, but I'm going to go over here real quick. So if this is my graph, and I know it's going to go down, I would have a point that goes here, and then I would have a point that's going to keep going. So my curve is going to keep going like this, right? But this tells me I only care about what happens when x is greater than 1. And I think this is a typo, but it's okay. We can still do it this way. So when x is greater than 1, that means I'm going to go in here and delete this part of my graph because I only care what happens when x is greater than 1. So I'm going to have another closed-in circle because it's equal, and then my graph is going to look like this. It's going to be kind of a little bit rounded because remember it should go up to this point if it was fully a quadratic. So this is the only part of my graph. Now I could have gone in here, I'm going to do this in pencil really light, and I could have gone in here and I could have graphed the whole thing like this, right? This is what my whole, it's not very rounded, it needs to be probably a little bit more rounded, but that's what it would look like if I was just to graph this guy, right? And so just like with this pink one, with my absolute value, if I was to keep going, I could keep going and it would look like this. But that's not what we want. We only want the parts of the graph that are in the domain, and that's what this part is. This is the domain right here. And remember, the domain are your x values. So because of that, I don't need any of this other part. All I care about is the pink line and the blue line. And we don't want this dot right here. Okay? All right, let's do another one. All right, this one has 3 parts to it. So let me start with this one. So I know I have a line, and my line on this case, I only care about what happens when I get to x equals -2. So if I draw this line, I start at -1, and I have a positive slope. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. So this is what my line looks like, but I only care about what happens when I'm at -2. So when I draw this line, I'm going to have an open circle here when x equals -2, and my line is going to go this direction because it's less than. All right, let's look at the next one. So this next one, I'm going to have a parabola, and the parabola is only between -2 and 0. So it's only going to be in here somewhere. All right, so what I know is that my vertex is -1, -1. So I have a vertex here at -1, -1. So here's my vertex. Yeah, that's right. That's my vertex. But I'm only going to -2, and this is going up. So this is where I'm going to end my graph. And on this side, this is where I'm going to end my graph, because I only care about what happens from -2 to 0. And both of those are equal signs. So this is closed in circle. This is closed in circle. My parabola is at -1, right? -1, -1. So it's just going to be like that. That's all I have. Okay, so now let's look at this last part. I'll make this, oh, that's black. Here, let's make this green. All right, so I know this green one is going to be a square root function. That's what this is going to look like. And so I would normally start at 0, 1. Well, that's what this has. It has me starting at 0. So this is perfect. So 0, 1. And this is going to be an open circle because it's not included. So 0, 1 is where I'm starting. And then I know my standard graph is going to be 1 up. And so this part of my graph is going to look like this. So everything's included. I have this part here that's from less than -2, and then I have this, which is between -2 and 0, and then I have this last part right here, which is greater than 0, this one. Okay, and I know that these are tricky. There's a lot of stuff that you have to remember, and if you need to graph the whole thing and erase it, that's fine. Just make sure that when you erase it well enough that you can, so that I can see what you're ending up with. Okay, so now we're going to talk about creating the equations for these lines. So here's this first one. It tells us it's an absolute value that's down with a vertex of -3 and 2. So if I look at this, that's this part of my graph. And it looks like it ends right here because then something changes. So if I look at this pink part of my graph, what I have here is that this is true. This is true. I'm creating the domain when x is less than or equal to 0. And we don't know if this is an open circle or a closed circle, but I'm just going to say that it's a closed circle. So it's less than or equal to. All right, this is just a line. This is just a line that says y equals -1, and that's what I have right here. I just have this line right here at y equals -1, and what I'm going to say is I'm going to start at 0, and x is this value right here, and I'm going to end at 1, 2, 3. All right, and then this is the last part of my graph. It's this part right here, and I see that that's a cubic function, which it is. It's a cubic function, and so I'm starting here at 4, so my points would be this point and this point, so that matches up. And what happens is this is going to be when x is greater than or equal to 1, 2, 3. So this is a critical point right here. This is at that point 3 when the two graphs meet, and that's what I have right here. And this is a critical point, and it's when these two graphs meet, that's at 0, and that's what I have right here. All right, one more part to this, and that is creating the equation from the graph. So we look at this first one, and we know that this is a quadratic, right? We know that this is a quadratic, and I know that it's going to be anything less than 0, so it's going to stop right here. So for me to create the equation here, I have to know what my vertex is. So my vertex is -2, -2. So my vertex is -2, -2. All right, and then the other thing that I need when I create an equation of a quadratic is I have to know my value to the left and right of the vertex, and it's 1, which makes it easy. So this equation is going to be x plus 2, because remember it's opposite of what we think. So x plus 2 squared, because it's a quadratic, minus 2. All right, now if you think about what we did up here, we have this equation of a line. Whenever we have something that's just a horizontal line like this, like I have right here, this is just an equation of a line. And so this line happens at 2. Now, don't get jammed up, because if I have an equation of a line like this, this would be y equals 2. Okay? If I have an equation of a line that looks like this is going to be y equals x plus 1. So we could have an equation, if we have a slope, we have an equation that looks this way, right? On my piecewise function, if I have just a horizontal line, that's just the value. Because remember, this is like saying y. So y equals 2, right? Let's look at the last one. The last one is this absolute value function. All right, so I need my vertex. So my vertex here happens at 1, 2, 3, 4, 5, 4. And I know that the whole thing is shaped down. And then the next thing I do is I want to check my slope of that first point, and I see it's 1. So my graph is facing down. My absolute value with my vertex is x minus 5 plus 4. Remember, it's opposite of what we think, so we're going to go down 5, and then we went up 4, and that's plus 4. I think that's it. Yep, that's it. I know these are tricky. Take your time. Come see me, and I can give you some extra examples if you need to work some more problems.